Here's a boy who's experiencing extreme thirst. Due to severe heat, he did everything to quench his thirst. He ran around and even tripped down, and ran around and got tired, not until he found a water bottle. He went to reach it, but then felt dizzy all of a sudden. And then,
Nangyari dyan, pre? Naimatay, pre.
Ano ginagawa niyo riyan? Bakit tinitingnan niyo lamang? Bigyan niyo yun ng tubig!
Saan naman tayo kukuha?
Water is one of the basic necessities of a human being. But how do we get water? Where does the water that we drink came from, Sophie?
Good question. Let's talk about what water makes up for. Let's talk about the hydrosphere. It constitutes all the water supplies to the earth in all its forms. It comprises 71% of the earth's atmosphere.
Earth's water surface, the finite amount of water on the earth, slowly added by volcanic eruptions and meteors from space that has lasted for billions of years. This is the illustration that shows the percentage of water on the earth's surface.
Wow, that's surprising. Did you know that water has a residence time? The residence time of the water is the average length of time they spend in the reservoir. The larger the reservoir, the longer time water spent in them. Oceans has about 4,000 years residence time, ice cap has 800 years, deep groundwater has 10,000 years residence time, lakes has a few years of residence time, soil moisture has 1 year of residence time, atmosphere has 11 days, and rivers has a few weeks of residence time.
There are several types of water reservoir, and water forms are the following. The first type of reservoir, we have the saltwater reservoir. From the word salt, this water is salty. Of course, it constitutes at least 97% of the total water supply on Earth. Because of its saltiness, it must be distilled and refined before it can be used for consumption. The best example of salt water is the ocean. Came from the Greek word oceanus, which they believe to be a large river that surrounds the entire land. The total volume of the world's ocean is approximately 1.35 by 109 cubic kilometers. So, how many oceans do we have? Yes, Glydel?
The Earth contains 5 oceans. Pacific Ocean, Atlantic Ocean, Southern Ocean, Indian Ocean, and Arctic Ocean.
What do you notice about the water on some beaches, oceans, and seas? How do they taste? Salty, right? Well, the measure of the water saltiness is called salinity. Oceans become salty because of the minerals that have been carried into the water from rocks and from the underground volcano eruptions. Oceans have several zones. Let's take a look at this.
surface or layer zone is composed mainly of low-density, warm, and a home to most marine life on Earth. Thermocline is the second layer of the ocean, typically starting around 200 meters and extending to about 1,500 meters below sea level. It is often divided into two distinct zones. First is the mesopelagic zone, which experiences diminishing sunlight but is still partially illuminated. Next is the bathypelagic zone, which is completely dark as sunlight cannot penetrate this depth, marking the beginning of the deep ocean. Next, we have the deep zone. The deepest layer of the ocean consists of uniformly low temperatures and contains at least 80% of the total salt water. It is divided into two zones. First, the abyssopelagic zone, 4,000 to 6,000 meters deep and is completely dark as sunlight cannot reach it. And next is the hadal zone, starting at depth of 6,000 meters. This zone is the darkest part of the ocean and reaches the ocean basin.
Let's talk about water current. Mael?
Yes, Sophia. Water current refers to the movement of water influenced by various factors. It can be categorized in two main types. Surface current. These currents are driven by surface air movements and occur in the upper layer of the ocean, typically at depths of 50 to 100 meters. In the northern hemisphere, surface current move in clockwise direction, while in the southern hemisphere, they move counterclockwise locally. Water current tend to move in a clockwise direction regardless of hemisphere. Thermohaline circulation current. This refers to the movement of water in the deep ocean, driven by differences in density related to temperature and salinity. with thermo meaning heat and haline referring to salt.
Freshwater reservoir. Most of the Earth's freshwater is stored in glaciers and ice sheets, which are often in remote regions. The only accessible and potable freshwater is found on the surface of the Earth and underground. Glacier. Glacier is a permanent mass of solidified water formed from compacted to crystallized snow, while ice sheet is a large mass of glacial ice covering over 50,000 square kilometers, usually found in Greenland and Antarctica. Permafrost is any area of the lithosphere or stratosphere that has been frozen for over 2 years. It is primarily found in polar regions and can reach depth up to 150 meters. Permafrost contains an estimated 300,000 cubic kilometers of fresh water.
Surface water. Surface water includes various forms of water bodies, each with distinct characteristics. Streams. Moving bodies of surface water flowing downslope in defined channels. Rivers. Larger streams with a greater volume of water, flowing in a well-defined channels. Lakes. Large inland bodies of water, either fresh or saline, formed in depression and supplied by the rivers, streams, overland flow, and groundwater. Wetlands. Areas are primarily covered with water, supporting specialized biological life. Wetlands are sensitive to changes in water levels and include 3 types. Marshes. Shallow wetlands with grass and reeds, found around lakes and oceans. Swamps. Wetland with lush vegetations and trees located beside slow-moving rivers. Estuaries. Coastal bodies of water where freshwater meets saltwater, home to organisms that adapt to varying salinity. Groundwater. Groundwater is fresh water located in rock and soil layers beneath the Earth's surface, making it the largest liquid freshwater source on the planet. Key features include aquifers, underground rock layers that contain groundwater. Their ability to hold water is determined by porosity, the amount of space between soil particles, and permeability, the ability of soil to allow liquids to pass through. Unconfined aquifers, also known as water table aquifers. These allow groundwater to rise freely to its natural level. Confined aquifers, also called artesian aquifers. These are trapped below impermeable rock layers, creating pressure that can cause the water to rise.
Groundwater profile. The groundwater profile consists of several distinct layers. Soil layer. This moist layer indicates the presence of groundwater and helps determine suitable location for well constructions. Unsaturated zone, also known as zone aerations. This layer contains loose particles and air, allowing for drainage. Saturated zone. This layer is fully filled with water, where loose particles are saturated. Water table. This boundary separates an unsaturated and saturated zones. Its shape varies according to the topography of the area, and its water supply fluctuates with seasonal changes.
Flooding. A flood is a natural event where typically dry land becomes submerged underwater. The severity of a flood is influenced by factors such as flood size duration, which can range from weeks to rapidly receding, and the extent of the affected area. Key factors contributing to flooding include higher precipitation rates than the ground's absorption capacity or stream drainage, the collapse of man-made or natural reservoirs during dry periods. Types of flood include fluvial floods, also known as riverine floods. These occur when stream discharges exceed the channel's capacity, causing overflow. Next is the fluvial floods, also known as the surface water floods. This happens due to heavy rainfall creating floods independent of river overflow in urban areas with clogged drainage systems. Next is the flash flood, intense high-velocity torrents of water that occur with little or no warning in river channels. Next is coastal floods, flooding that affects low-lying coastal areas, typically due to severe weather events like storm surges or tsunamis.
Water as a resource. Water is a vital resource for humans. With this being said, there is uses vary depending on the location. For example,
Coastal areas offer fishing and seafaring activities. River banks near floodplains support agriculture. And today, water is essential for food, drinking, transportation, religious practices, and recreational activities.
Human activities affecting water quality. Not all water has good quality. There are instances that water can become contaminated. So here are the factors that affects water quality. Number 1, population growth. Number 2, migration from rural settlements to urbanized areas. Number 3, demands for greater food security and higher living standards. And number 4, increased competition. And last but not the least, population from factories, cities, and farmlands.
There are other activities for water degradation. First is sedimentation. It is the changes in the environment that degrade the local ecosystem. This includes the following: deforestation, conversion of natural landscapes into farm or residential areas, urban growth, road building, and surface mining. Next is acid mine drainage. Mining of certain metals create acid compounds once the water is exposed to such binding elements or compound. Then, we have improper waste disposal. Pollutants accumulate, inciting pollution to such areas. Some examples of waste are industrial waste, sewage, harmful chemicals, and chemical emissions from vehicles and factories. Another thing, we have overexploitation of known water supplies. It is the instances where water supply is disrupted due to excessive use of it. And lastly, we have the use of water in response to natural phenomenon. Some examples are severe drought due to El Nino, severe rains due to La Nina, and climate change and global warming. We have the Republic Act number 8041 of 1995, which addresses the Philippine water problems.
Thank you.